Morning and good afternoon, everyone, and welcome to the panel discussion on urban water bodies and their management. The world is witnessing rural to urban migration at a rapid pace, and it is expected that 70% of the global population shall be living in cities by 2050. Now, this rapid growth of urban population has changed the city landscapes through construction of roads and building and other impervious surfaces which prevent water from infiltrating, resulting in urban flooding and the polluted runoff draining directly into our surface water bodies. In addition, the city water repositories have also been encroached upon and reclaimed for infrastructure development. To add to the water woes, 80% of the global wastewater is released into the environment without adequate treatment. Urbanization has disturbed the hydrological cycle of cities, and urban water management systems must consider future pressures, which include climate change, rising sea levels, socioeconomic diversities, policy and governance framework, and the continuing growth of global urban population while planning and implementation of projects. In the backdrop of this monumental changes that we have done to our urban landscape, this discussion shall focus on few measures that can be taken to alleviate or mitigate these issues and make our cities resilient and water secure. We have with us an eminent panel who shall share their views on the problem. Our first panelist is Dr. Shekhar Muddu, who is a professor in the Department of Civil Engineering, Indian Institute of Science, Bangalore. His chief research interests are analysis, modeling, and process understanding of groundwater systems, satellite hydrology, etc. He is collaborating with interdisciplinary teams on integrated hydrological and geochemical catchment experiments and is the lead member of the Kabini River Critical Zone Observatory and assimilation of multi-satellite data at Berambari Watershed for Hydrology and Land Surface Experiment, AMBHAS project. Welcome, Dr. Muddu. Our second panelist is Dr. Hella Scholzmuller, Head of Groundwater Department, Kompetenzentrum Wasser, Berlin. Dr. Hella has more than 15 years of experience in managing and coordinating projects in the field of groundwater resources with focus on drinking water wells, drinking water supply under changing climatic conditions, and decision support systems. Since 2015, she is head of the groundwater department at Berlin Center of Competence for Water. Currently, she is managing the H 2020 project, Digital Water City. Welcome, Dr. Hella. Our third panelist for this session is Mr. Ganesh Shankar, who is the founder and CEO of FluxGen. Ganesh is a serial entrepreneur in sustainability and clean tech space. He is the founder and CEO of FluxGen Technologies and founder and director of the nonprofit, the Sustainability Mafia. He has also been an adjunct faculty at the Center for Continuing Education at the Indian Institute of Science, Bangalore, as he enjoys sharing his knowledge in IoT and clean tech. I am Fawzia Tarannum, Assistant Professor in the Department of Regional Water Studies at the Terry School of Advanced Studies, New Delhi. And my interests are in water governance, conservation, gender in water, integrated water resources management, and youth engagement programs on SDGs and climate change. So we shall first have the panelists present for 15 minutes each, followed by question and answers. The participants are requested to use the chat option that is there very liberally to type their questions. And please type the name of the panelist who you wish to address the question to. You may keep typing the questions during the course of the presentation and not wait for all the presentations to end, so that we have lots of questions coming in the chat box. It's my request to all the panelists to keep their presentations within 15 minutes. So with that, I would like to move on to my first panelist. With groundwater levels depleting at an alarming rate, it's crucial to maintain and groundwater having a very, very critical role in maintaining the environmental flow in the surface water bodies during lean season. I would really like to invite Professor Shekhar to share his work on managed aquifer recharge and drainage planning of cities to ensure that we have our groundwater as well as urban water bodies sustainably managed. Over to you, Professor Shekhar.
Thank you, Dr. Fazia, and also welcome to all the panelists in this session on urban water bodies and their management. So special welcome to Dr. Hella and Shankar. I hope you can hear me. As Dr. Fazia introduced, I will speak on the part of urban groundwater, which is an important link in the total urban water body and their management. So as you can see, I'm going to the next slide, where the idea is that typically in an urban context, the groundwater system is quite complex. As you can see in the view graph here, the cities will have water coming from other sources for utilization of water resources, plus there will be some amount of water picked up from the could be balanced in some cities. In some towns it could be completely surface water driven. That means you impound water from far and wide, or you could have completely the groundwater in the system. I'll show you some of these points. And then the used water essentially goes back away from as a drainage away from the city, or it could infiltrate down into the aquifer. So typically, if someone is bringing a lot of groundwater from far and wide, it is possible that the water is the groundwater coming to the city in that region, the groundwater levels could go down, and there is a lot of recharge taking place within the town. The groundwater levels could become shallower and higher. So typically, unlike in an agricultural landscape or a typical landscape of a non-urban setting, the groundwater gets complex setting in an urban system. There are several reasons for that. Some of them are listed over here. Like typically, we may have a rainfall from recharge. There can be conventional recharge, which we call it as a recharge going through the soil and recharging the groundwater, or we could have indirect recharge. Indirect recharge meaning the water which falls on the ground will quickly run away from the place because it's paved and things like that. It will become a runoff and then lead to some other location where it can recharge indirectly. It's possible that there are pits and some other crevices and so on. So we distinguish this as a natural recharge and an indirect recharge, which often happens in urban cities because you pave them. There could be also leakage from harvesting operations. Typically in many Indian towns and cities, we are trying to push back water in various ways into the ground. So we can call them as harvesting operations. Then you have also groundwater use. Then also the infrastructure underground could impact with the groundwater flow patterns. So these are some of the reasons for the complex setting of urban groundwater. Typically,
we are very sorry. We have lost Professor Muddu at this point in time. So I would like to move on to the next speaker and would like to invite Dr. Hella, who has been working on the EU Horizon 2020 project, Digital Water City. She has been working on urban water cycle and urban water infrastructure management with focus on three issues: public health and protection, performance of infrastructure, and public awareness using augmented reality. I would like to invite Dr. Hella to share her work and how it can be applied to Indian context, where almost 65% of the domestic sewage and 50% of the industrial effluent go untreated into our water bodies. Over to you, Dr. Hella.
Thank you, Faisa. I hope you can hear me now. Yes.
Yes, we can hear you.
Thank you for the invitation, and I'm happy to be here today to introduce you to our Horizon 2020 project, Digital Water City, which is aiming at leading urban water management to its digital future. And as Faisa already said, I will focus on three solutions, but also try to give you an overview about our project on total. Start with our objectives and just showing DWC as the project is abbreviated in a few words. So what we want to do is to connect and boost digital technologies for water and wastewater infrastructures. And we do this in 5 case studies, which I will show with my next slide. So the aim is also to develop business, to promote the value of the solutions for the technology providers, and to make the connections to the utilities, that is the water and wastewater service providers, and to achieve a new step in the integration of digital solutions in Europe, but also, of course, making the EU a forerunner in this field world. We have together 3 research work packages, which are aiming at minimizing health risks in water reuse and bathing water by improved decision support, but also boosting the efficiency of operation and management of water and wastewater infrastructure and serial networks, and empower online decision-making processes. While we are thirdly, we have a work package on public involvement. So we want also to show how we can govern these solutions and how we can increase the public awareness of the whole water cycle. So as Faisal said, coordinated is this project by the Berlin Center of Competence for Water. We are a small non-for-profit research institute. We deal with all aspects of the urban water cycle, and we do this with about 30 researchers, and we are based in Berlin. So we do this project, of course, not alone, but together with 24 partners, which are mainly coming from companies and SMEs, but also from R&D partners, from universities and research centers, such as we are. So, for example, the Norwegian, from Norwegian or French research. And we have, as said, 5 case study cities and their utilities, which are partnering with us and deploying the digital solutions developed here. 5 case studies here on our next slide. These are Paris, and in Paris we aim at improving the bathing water quality of the River Seine, targeting the Olympic Games of 2024. And there we will develop an early warning system to manage bathing authorization in each of the official bathing places there. We built with this project on solutions we already developed and deployed in Berlin. Berlin is another of our 5 case studies, together with the Berlin Water Supply and Wastewater Service Company, Berliner Wasserbetriebe. Here we aim at improving the infrastructure performance. We propose a new software for proactive maintenance and strategic planning of drinking water wells, but also innovative sensors for the monitoring of combined zero overflows and illicit connections. And I will show this as one of the examples where I thought there might be some relation to other contexts outside, and especially to the Indian context. Our next case study city is Copenhagen. In Copenhagen, we aim to reduce the environmental impact and the flooding. This also is addressing combined zero overflows, but also the management of the whole wastewater treatment system and the sewer networks by activating in-sewer retention capacities and by developing decision support systems, how to manage and how to control flows in the sewers and in the wastewater treatment plants. And Sofia is one of our case studies. There it aims to optimize investments and reduce operational costs. It also has a very large part in combined zero overflow monitoring technologies and management of the sewer network, where I will show some solutions. And there is also an innovative sewer cleaning solution tested, which combines cleaning with inspection of the sewer network. And finally, our 5th case study is Milan. In Milan, the goal is to achieve safe water reuse for agricultural irrigation. So there we developed, for example, technologies like drones for water stress monitoring, and then a matchmaking platform to support the allocation of treated wastewater for reuse. So this being said, to our case study cities, I would like to show briefly a bit all of the solutions and go into detail for 3 selected digital solutions which we developed. So I start maybe not really along the water cycle, but along the consumption cycle. I start with drinking water, and there, as said, we developed which is addressing the predictive asset management of drinking water wells. I will not go into detail here, but I just show it as I want to introduce the whole project. So apart from, or if we speak about the whole water cycle, we address basically more or less all parts of it. So the drinking water production, and as said, wastewater treatment, sewer, water, surface waters. What we not address is drinking water distribution networks. So you will not find any solution on water leakage or other issues which happen in the drinking water network. We are, of course, aware of this as research institute, but this is not part of the Digital Water City project. So this being said, I come directly to sewers. I will show some more insights into the solutions. So there we have several targets or several objectives, also several technology providers which work on these topics. And one of these is that we want to improve the monitoring of illicit connections. We do this by various sensors, such as, for example, distributed temperature sensing, or electric conductivity sensors in the sewer network. We then aim at the monitoring of the whole sewer network and management of combined sewer overflows by low-cost sensors. And this is this monitoring technology with temperature sensors, which I will show in my next slide in detail. And what we do with all these data we obtain, we want to do some advanced 48-hour sewer flow forecasting, as said, to improve the management not only of the sewer network, but also of the wastewater treatment plants to increase retention capacities in the system. And I show you here one of the solutions for sewer monitoring. So these are these low-cost temperature sensors, which are deployed to understand the occurrence and the duration of combined sewer overflows. So it's just a combination of very simple and low-cost temperature sensors that are installed in the combined sewers. And once they get in contact with water, so we have two sensors, and the difference between the normal flow conditions and the high flow conditions, which then lead to a sewer overflow or might lead to a sewer overflow. And just from the difference in temperatures between these two sensors and between low flow and high flow conditions, we get a better understanding of the total flow situations and how we can manage the retention capacity within the system. This is in the project, also combined with, for example, weather forecasts, radar data to manage the whole system, and also to provide decision support in the cases where this management belongs to different utilities or different units in the whole system, as it is, for example, in Copenhagen, where 8 utilities altogether are responsible for treating the wastewater of the greater Copenhagen area. And they do this by a web platform. And just by adding these sensor information and model information, rain data, radar data, forecasts, they can improve the decision making in the whole management system. So this being said, I jump directly to the wastewater treatment plants. And there we focus on 2 aspects. So one, as said, is the real-time control of the retention capacities. So this is what I already explained. And the other part is that we want to develop and deploy an early warning system for water reuse. This aims at delivering a sanitation safety plan on the wastewater treatment plant, which has, to our knowledge, not been done before. So we know the water safety plans, but we don't have any sanitation safety plan. And for this, for example, in also a health institute is one of the partners in the project, which are basically the responsible authority for developing such plans. Also here, I show some details of the solution. If I can switch the slides. Here we are. As said, the specific solutions are remote monitoring of water stress. This is done by drones. And the other part, or the other big part in this context, is the matchmaking platform to support water allocation. We do this in Milan on the wastewater treatment plant there. And what we basically want to do is that we connect the wastewater treatment, the water utility, to irrigation infrastructure, to farmers associations, and to really, develop a system, a controlled system of water reuse where sensors are deployed, which give early warning of any contamination, if there is, or which reports on the water quality targets. And with these water quality targets given, we can then match with demands of the farmers who need different quality targets for their irrigation plants and for their irrigation of different crops. So this is also in another solution. This is also translated into a serious game, also to inform the public about this issue and about the water, food, energy nexus in this context. So the next solution I want to show, and this is also partly related to the water reuse, but more to bathing water, is a real-time measurement of bacterial contamination, which will then feed into an early warning system to forecast bathing water quality and communicate with the public. But the same system is also deployed in the wastewater treatment plant to inform about bacterial contamination in water reuse schemes. And I show you this solution here. It is a sensor which is developed by a technology provider based in Paris and which has been deployed there, but as well here in the project, not only in Paris in the bathing water context, but also in Berlin in the bathing water context as well, and in Milan on the wastewater treatment plant, as said, to give an early warning for any bacterial contamination events which may prevent the reuse of the water, or in the other two cities which may prevent the use as bathing waters. So as said, we also develop dedicated solutions, specific solutions to inform the public, and these are not only the ones who wish to bath or swim in the rivers or to reuse any treated water as they are farmers. We also have two apps for the general public, and these are an augmented reality application to communicate groundwater issues and to also show the retention capacity of the soils of the groundwater passage in managed aquifer recharge schemes and bank filtration schemes, which is a very important topic here in the Berlin context, but also in other places in Germany and in Europe. And therefore, we couple a geological structural model with numerical flow modeling to inform about what is happening with the water, but also what is happening with any potential contamination, what is happening with well operation in the subsurface. And as said, for the reuse context, there is a serious game to communicate the nexus issues of water reuse. I want to just also briefly show the solution for our augmented reality for groundwater. And this is named Making Groundwater Visible. As said, we coupled a structural geological model, which you see on the picture. This was already pre-existing, I must say. So this was developed by the Berlin Senate Department of the Environment in the last years. And we could build on this solution. So we already had a 3D structural model of the geology, and we are now about to couple this with numerical flow modeling and implement it in the augmented reality. And then you can virtually dive into the groundwater aquifers and follow the water from surface waters or managed aquifer recharge basins up to the wells where the drinking water is abstracted and produced. So with this, I would like to conclude, and I also would like to invite you to visit our webpage. There you find a lot more information about the case study cities, but also, of course, on our solutions. You also find video testimonials there, or can get in touch with us if you want to know more about the utilities, about the technology providers, or about the research partners here. And yeah, I thank you for having the chance to be here today and for your interest. And I hand over back to Faisal. Thank you.
Thank you very much, Hella. Extremely informative, very useful for India. I think most of the components that you spoke about, whether it was related to combined sewer overflow, so that's something that we have been experiencing a lot. In fact, especially because of climate change, when we are having intense rainfall, very short duration of time, our city drains are not equipped to really handle. And with stormwater drain and sewage getting combined together, they are definitely getting overwhelmed. The second thing is on the sewer monitoring, probably for us, it's almost about 35% of our raw sewage gets treated, sewage gets treated, and the rest lands up directly into our water bodies. Likewise, even our industrial effluent, almost 50% of our industrial effluent gets into, without treatment, it gets into our water body. So probably the tools that you have spoken about, especially the monitoring, the surveillance tools, they are extremely useful in the Indian context as well. Again, bathing water quality, that is there. That's again important. We do have certain guidelines which are there for the best use of water, the water quality parameters, but then real-time monitoring is perhaps very beneficial on how people are using the water that is there. And lastly, about the public awareness program, of course, that's a very important component in any project, not just maybe awareness at the same time, participation of public, so that we can go in for a long-term sustainability of these programs. So many thanks, Hella, for sharing the insights from your H 2020 project. We will take questions later. I would like to once again invite Professor Muddu, if you are around, to please present your topic. So since I don't see any response from his end, we will move to our next panelist. So our next panelist is Mr. Ganesh, who has set up the startup FluxGen. Often what happens is decisions related to water management are affected due to lack of data, and sometimes due to disorganization of data as well. So government, of course, is collecting a lot of data related to water quality, related to groundwater, but these databases are not managed properly. The sheer enormity of the numbers, overwhelms that. And here we have Mr. Ganesh, who is doing work on how digital technology can be used for managing this data. So over to you, Mr. Ganesh.
Thank you so much again for this opportunity, and I would also like to mention that I had presented with considering the fact that Dr. Hella and Dr. Mudhu would have shared about the aspects of various aspects of water management and water related aspect, whether it's in groundwater or city-wise management. So I would like to stress upon the fact that how an entrepreneur or an engineer or a graduate or a PhD student can actually consider a alternate career path of entrepreneurship, setting up a company. And I wanted to share a bit of my own journey and also tell about how digital technologies can actually solve this problem. And it also want to emphasize a bit more on the industrial water management, because that's the area I work in. And I hope this presentation of mine is of some value for people who are thinking, sitting in the corner of the room, thinking whether they would be able to do something on their own. Maybe hopefully this opens up some ideas to do so. Yeah, so I'm dividing the whole presentation in terms of the context of water. What is it to me? Why did I even start this thing? And a bit about journey as an entrepreneur in this field, and say how I eventually bumped into water management, and how digital technologies, like I believe, are going to play a little bit of a major role in this. And in industrial water management, what is the challenges? What challenges are industries facing today, and what is that is there for aspiring entrepreneurs in this thing? And most importantly, how water is leading to water crisis is leading to taking proactive steps by industries, and how it is driven by investors through the form of ESG. environment, social, and governance. And maybe I'll end with something which is going to inspire you a bit on what, as an individual, you could do. Okay, so I grew up in the city of Bangalore, right? And I remember when I was in early childhood, in my own home, we used to have a small well, not a borewell, a proper well, and the water used to come in hardly 10 to 50 feet of water. We used to get water within 10 to 15 feet. By the time I went to high school, actually water wasn't there in the borewell, and so we were dependent entirely on the water coming from the BWSSB, the local authority, Metro Water, right? And then by the time I went to college, we actually didn't have much water, so we had to put a. I mean, my father got a tank in when I went to high school. By the time when I went to college, we also got a sump at home, right? I mean, because filling it up. And by the time I went to engineering, we were also even getting water tanks. So this made me feel very concerned, right? In my own lifetime, I've seen water at different levels, whether it is getting it in a well to eventually getting water from tankers. And I see, at least I had a privilege to, and I have food and education, right? And educated parents. So, but if you think of a city like Bangalore, and you know there's a lot of people who don't even have access and dependent on tanker. This perhaps was an inspiration for me, or rather, as a countryman, you are concerned as a countryman. Like, but I also saw its opportunity as an engineer to work on water management solution. So yeah, after graduating from University of Science, I ended up working for a large major, that is General Electric, in their aerospace, and later in their digital energy division. That's when I got an understanding of what digital technologies can do in utilities, and that led to me eventually starting the company FluxGen. So this picture, of course, is something that I felt good to share when we set up this company, and we were doing water management for industries, and we were actually setting up this systems in industries like Titan, Britannia, various companies. We were actually came to know Google actually found us out. I don't know. We always find things in Google, and Google team actually found us out, and they actually came all the way from Mountain View to meet us in our lab. So, and it's a picture from there where we are explaining what we are doing. So from an idea of that, if you don't measure, you cannot manage, we actually started monitoring water systems at industrial level, right? And I should also thank my own alma mater, Institute of Science, the WHR Center for Climate Change, is where we did some of the projects before we start doing for many corporates. So what we realized was that though the water availability has changed drastically over a period of time, but we were still using prehistoric ways of managing water. I'm glad to see the work that Dr. Hella is doing. That's a kind of advancement that we should have in water management. Unfortunately, while I talk, we still use very poor ways of manual ledger, taking hand readings of water in various places and in an industry, and we find out they put it on an Excel sheet and try to find out what. So through these methods, we were not even able to identify whether there is leakage, wastage, or excessive usage of water. So I realized if you don't measure, you can't manage. So we started out as putting up this monitoring systems, like whether it is a IoT based system to monitor water flow, water level, and eventually gather all this data. So as I said, it's just not only about getting this data. Once you get this data, how do you utilize it? That's where I come to the point that we realize that it's just not one digital technology that can be utilized. Like Dr. Ella talked about virtual reality, augmented reality, rather. So that's something that I would also like to you see about it. But what we realized was at a fundamental level, for any system that you want to manage, right? And you also want to give prescriptive alerts where you would actually able to identify if there's a leakage, wastage. You want to give alerts to the ground staff. Perhaps you might start with a simple IoT based system, but it doesn't end there. So it's basically convergence of multiple digital technology. We are just in the cusp of using some of this technology. To acquire data, you would use Internet of Things, right? Internet of Things is basically you would be able to have a sensor. The sensors would able is connected to microcontroller. The microcontroller is connected to a cloud network, right? I mean a secure cloud. I mean basically with a secure. Once this data goes to the cloud, you want to make sure that this data is not tampered. Like of course if it's there in the cloud, you could actually change the data because it's all connected to the a cloud server, right? I mean a programmer or this one. So you don't want that to happen, especially when it comes to water, right? I mean, you don't want that to be tampered. That's why you would probably need a distributed ledger. So distributed ledger is like an immutable ledger. You can't change once it gets there, and it's a very decentralized ledger. So that's why you would need DLT. Distributed ledger is also, I mean, many times called as a blockchain, right? And a blockchain is many times only seen from the Bitcoin point of view, but it's not necessarily that blockchain is used only for the currency exchange. Of course, so you could actually put this water data onto a distributed ledger, so ensuring that there's no possibility of tamper and nobody can fool around that data. And then, of course, you would even consider using various methods of engaging in coordination, whether it's crypto access or so. But most importantly, at the end of the day, all this data that you are getting, whether it's a water data in an industry or even in a lake, or even for that matter, the data that goes through a large, mining industry or iron and steel industry, is that using these data, can you come up with an understanding of how this data can be utilized to manage this facility better? Like whether it is in terms of leakage detection, wastage of things. So that's where you would use the machine learning algorithms to identify the possibility of various abnormalities, anomalies, and so. So that's where the AI comes into picture. So this is what was I thought. I mean, I was mostly equipped, considering the fact that I come from graduated from Institute of Science and Supercomputer Education Research Center and Instrumentation Applied Physics. I thought I should utilize these technology while if you consider the entertainment industry or gaming industry, which is utilizing to the core, we have not been utilizing the digital technology to a large extent. I should also say, many people ask, like, do you really want to use digital technology to do this? I ask this question. The amount of data that goes through your Netflix video in 1 hour is probably the enough data to manage the entire city. So when we have so much of data that is we are using for entertainment, why not apply it for managing our water resource, which is something that we need, right? So that's a premise. I believe why digital technology should not be like seen as a overkill, but it's rather so important that various other industries, retail industry has been utilized. So that's where we should move from the prehistoric way of managing water, right? So yeah, I mean, like I'll go a little bit depth into this because this is the core of my understanding in being an entrepreneur in using digital technologies for water management. So what we figured out was when we actually visit a facility, or even for a matter a township or a small city kind of a thing. So generally, you would have a person either in a motorbike or a cycle going across the campus, taking hand readings of water everywhere, right? And even today, I get the BWSSB person comes to my home taking hand readings. So while I'm talking to you, right? So that's something that can be easily avoided because we have wireless communication network or talk of whether it's IoT network like LoRaWAN, long range wireless network, or whether you consider NB-IoT, which is an emerging technology, and all these technologies are already reaching a mature stage, right? And more than anything, we have been using wireless communication for our audio signals for almost like many years, right? I mean, almost like a couple of decades or more. So the GSM network is already available. So there are M2M SIMs which can actually send the data from any of this place, and the cost has actually come down. So once this data comes, and the thing that we realize is that despite all this water, I mean, we are getting 900 million liters of water from Kaveri River to Bangalore. Why do we still don't have water at times? Because there is nearly, at least a couple of years back, I used to read this. There's 50% of water meant, 50% of water was unaccounted in Bangalore. So this is where the digital technology can help. You can clearly know where that wastage is happening, where that leakage. So a lot of underground pipes today are unmonitored. So the pressure sensors could actually help in identifying where that leakage, wastage, excessive usage is happening. And maybe that's where I would go into depth. So I'd go to little components that could actually help you in making sure how AI can directly help you. AI, digital technologies can help. See, in terms of while all the systems are around, we still don't know what kind of contracts or what kind of design we should do. So, with if you go for a system like this, you would know an understanding of a system from a data-driven aspect. Like, and you would be able to figure out that using monitoring, you can even control the water networks. That's something that many of the advanced cities, I'm sure Hela would talk about it more during the Q&A session. You can detect. Today, we don't have a numerical way of detecting any loss of water. That actually can be managed through this artificial intelligence and identifying using the data pattern. And the very interesting aspect about water is that the amount of water that we consume is also the energy that was consumed in pumping, purifying, recycling, all that water. So using water data and AI into it, we can save huge amount of water. So if there is a connection with climate change mitigation, so water is mostly seen as a because of climate change, we'll have scarcity of water and water flooding or even drought can happen because it changes the water cycle. But the other aspect of mismanagement of water is directly impact on the climate change. Because of improper use of water, the energy that was utilized to manage water is today below the radar. Like if I'm getting water from 120 kilometers today, imagine the amount of energy that has gone. So, and likewise, if I actually have water availability monitored together and pump purified, the energy associated to that is probably figured out, and you would actually get a return on investment of your water resource. So many times the true cost of water is below iceberg. So that's where the energy cost comes in. So various contingency plans that can be managed with this water data. So the consumption pattern is today, since we don't even have a advanced water management, we don't even have the consumption pattern to even do a forecasting, demand forecast, right? I mean, during the festival season or seasonal variation, there's a water consumption changing, but how is that changing? So that's where the you could actually manage using the AI based system network. I mean, today if you want to expand a industrial locality, right, we don't even know the risks that are associated in terms of availability of water. So all this data, if it is there, you could actually, a corporate could make an assessment using this water data and optimally manage or even configure their operation according to what should be done. A distillery, I mean, a brewery would actually not set up a distillery in a place where there's not enough water. Right? I mean, of course, there are various other ways to do it, but still managing this risk. So, yeah, the active asset management of water. I mean, you would actually get alerts if there is if there's some kind of a failure of any system. If these data is 24/7 collected. Okay, so let me come a little bit of industrial water management. I've already spoken a bit during my earlier part of the presentation. So industries face various level of risk today in terms of water. It's not the actual cost of water they buy from the BWSSB or the metro water. It's also the associated cost in terms of the regulation, reputation, and comply. I mean, the credit water that they buy for. I mean, the reputation of how they are managing this water, and consider the fact that the recycling of system is still not advanced because of the economic and various reasons. I think that's where the challenges are. I would like to rather spend a little bit more on what are these risks. So water risks today are actually for industries are strategic. If there is no availability of water in a particular locality, this one, and it means an industry which is either it's a food processing, food and beverage industry, or this one, they might not be able to strategically expand. And the investors whom they are looking for, like the companies like the guys like the BlackRock, would not invest if there is a water scarcity in a location, and if they are not. Okay, so there is regulatory risk where now today your water has to be tracked, whether it is in terms of your borewell water, groundwater. This used to be not the case in India for a while now. Only it's about the start of this year we have this thing. And reputational risk. I mean, industries today, if they are extracting water where there's a lot of urban or rural locality, they are depriving water in the aquifers. That also leads to risk. So BlackRock has actually identified various industries that can actually go through this. I mean, which are our big vulnerable to these risks. Like you can see the agriculture or the food and beverage industries. So now, if from the urban context, some of these industries which are actually located in urban areas have to be really cautious on their plans on how do they do mitigate this. So these are something that is only possible if they actually manage the risk daily. Okay, so I come to the last part of my presentation. I may have overshoot by time. Sorry about it. But today, I mean, while I talk about my startup, I talk that there is an opportunity for all people in the field who want to take up sustainability startups, build sustainability startup. Because what used to be a CSR activity in terms of sustainability, water sustainability, has become a mandatory thing through environment, social governance as a key factor value driving. Today, no investor, as I told you, the investors in this large chain would not invest if you are not actually ESG de-risked, right? The top line growth today is dependent on. I mean, if I'm actually going to a shopping mall, I would not buy some company which is actually extracted water in a unethical manner or a unlawful way, right? So making sure that your water, this is directly for industries to be clear about how they're extracting water and how their governance in terms of water is. So that's the top line. So your business expands. Like today, some of the brands actually put end-to-end value visibility of their carbon footprint, right? I mean, Unilever does that. So while you get your label in terms of nutritional quality, now they even put the carbon footprint, like that water footprint. So big industries have already made pledges in terms of water for becoming water positive. That's one thing. I mean, like Apple actually has decided to become completely circular economy by 2030. The handset that you would buy would be completely not would not even cause any problem to the environment if the pledge goes. So the cost reduction, obviously, if you're reducing water consumption or energy consumption, you're reducing the cost. So technologies that can reduce these things also help them reduce carbon emission. Right, regulatory and legal. I mean, you'll not be able to even advertise or even promote your business if you're actually not being compliant to ESG today. Right, it's slowly moving in. So yeah, I mean, product. So basically, even if the expansion, a company which is not actually concerned about how the groundwater is properly used, or you're not the rainwater or all the water that it's not recycling this proper in a efficient way, would actually be in great risk. This is an opportunity for all startups. This didn't exist all these years, 10 years back. Today, this is a mandatory thing for industry. Who are going to supply? Because the traditional companies don't really have solutions in sustainability. That's why the sustainability is generally coming from the startup world. That's what I would recommend a lot of you to actually. Actually an advantage being a smaller company because yeah. Okay. It has been a very this one about water risk. I've told. I also think I come from the land of Mahatma. We believe that be the change you wish to see in the world, right? So I know this Hulimau Lake, which used to be completely with sewage water and water, which actually with weeds. I know the locality people actually went there and cleaned this lake and worked with the government to make sure this urban water body that was actually in stresses today, they themselves did it. So while my thesis is about how we could use digital technology, I would also want to say there's a thing that we as individual can do at our capacity. We should not mix up the fact that what we can do as an individual and what we can do in our work. So if
Ganesh, you may please conclude.
so, thank you so much. I think that was the last slide. Hey, it took a little more time, got little.
Yeah, many thanks, Ganesh. I think I know you do a lot of good work and with multiple stakeholders. So a lot of things definitely to share. But thank you very much. We will come back to you with few questions during the Q&A session. And since we are running out of time, I would once again request Professor Muddu if he is around. I'll just go back to your present slides and then you may please start. Thank you. And 15 minutes because we are just left with about 35 minutes now.
Probably, or less slides so that you can have panel discussion.
Please.
I'm sorry, I think I was lost in between or disconnected. I will continue from where I left for the panel. Of mentioning that there is an important portion of groundwater which is essentially in cities which gets gained by the leakage of water and wastewater pipelines. My predecessors have in the panel have mentioned about these aspects, but this is important because groundwater gains from this. These are a typical assessments of potential leakages. So if you are in India, we are talking about 30% of the water leaking to the groundwater system or the lossages in the leakage. So some of it appears in the groundwater, some could be not appears back into the groundwater system. So the point which I was trying to say is that there could be some places the groundwater can be depleted, some places groundwater levels rise in a cities depending upon the topography, depending on the operations, and that can be a cause. And the cause of concern could be in terms of, let's say, groundwater flooding, for example. It's an example of a flooding which can happen because of shallow groundwater tables due to rising levels, either from the nearby river or rising due to the non-use of groundwater, which in itself could be a major catastrophe because groundwater flooding will take a long time to get removed from the system. So it can have excessive water exfiltrate out of the system of urban infrastructure. Instead of infiltration, we're talking about exfiltration. So it can happen, as I said, due to a river in the neighborhood and a town, and then due to higher flood levels, my groundwater levels could go up due to this is a flooding happening in the neighborhood. Or it could be, it could also cause from various other things. So here we're talking about situations where land subsidence can happen. So when you are using groundwater, it can also cause land subsidence, especially if the soils are deformable, for example, clay soil. So you can see in the pictograph here, in some places you have several centimeters or even a meter or two, which can happen in terms of deformation. Some prominent ones, as you can see in parts of closer to Asia, you can see Tokyo and so on, where you have deformations. You are familiar with Venice, where Leaning Tower of Pisa, where you had deformation. So these are clay soils which can deform due to the groundwater use. So recent times, these are getting compounded. For example, there are concerns raised with due to subsidence. The flood waters are entering into infrastructure, which is often for coastal cities. So this is being noticed in parts of Florida and so on and so forth. So which is often the case. So similarly, you may have, this is a situation where sea level rise could cause also the groundwater inundation. So the water levels are rising due to climate change in many parts. So the seawater could intrude into the system, and here is an example shown in the form of inundations. It's also that the impact of underground infrastructure could impact with our groundwater systems. Here is an example, a cartoon of an urban conglomeration, and typically when you have large buildings like this, which is tall, you have an underground the foundations also go very deep, and they obstruct the free movement of groundwater. Thereby you can have rise in levels of groundwater in certain pockets. So here is an example of a situation. So in Hong Kong, the number of foundations were very few earlier, and then the number of deep foundations increased a large percentage, and that have caused externalities of rising the groundwater levels upstream, and then which can get affected by in terms of flooding issues. So I'm just trying to iterate various problems. So here is a system where infrastructure was a negative anomaly. This is an underground metro stations in Japan where the groundwater levels rose due to less utilization of groundwater, and thereby the water levels are now much higher than the original levels when the metros were designed. So these are happening because several cities in Asia, several cities in India, for example, are going through underground utilization for metro stations. Plus, we also use groundwater. So combination of use, non-use can have all these aspects. So important aspect which I wanted to say is that a drainage, which is often when we say landscape, when we do irrigation, when we say irrigation and drainage comes common in any system. So similarly, in an urban system also, we need to think about a sustainable drainage solutions systems. These drainages are to evacuate floodwater. Sometimes you have a lot of floodwaters happening in a city because existing channels, existing pathways are not anymore valid, are not adequate. So you need to think out of box. You need to create additional drainage pathways for this water, very similar to akin to like you have multiple transportation systems, maybe an underground road, above ground road, an elevated road. So when you do for transportation so many things, we also need to build solutions for evacuating the water. So that is what I mean by evacuating the flood waters. Similarly, you might want to create harvesting storage sites. When you have sudden rush of water during a season, you might want to use it for future in the right locations where you have an opportunity to store this water. Otherwise, it's causing a menace somewhere. So I think identifying where there is a storage possible in the city and diverting these waters could be another. And so the drainage to avoid the groundwater flood risk, for example, all of these are required drainage systems. So typically an Indian scenario, I'm just reverberating from an Indian scenario. Typically big cities have a large amount of surface water coming in, as you can see in the right side of the cartoon. But many towns and smaller towns are highly dependent on groundwater. So it is important to understand the availability, the resource, the constraints, and so on and so forth. Of course, the technology plays an important role. So what I will do is, in a quickly for you, you already listened a lot of presentations by the panel, to just to give you an idea of a case study which we were involved in the city of Bangalore, typically Bangalore is a big city, and we wanted to understand how the Bangalore is doing in terms of groundwater, because there is always alarmist issues on looking at what is happening to the groundwater, which we do not have a good assessment. So we had a project with Stockholm Environmental Institute, Institute of Management, and IASC, and a startup, Satyuk. Together, we all were working together to understand the groundwater system. So one of the questions which we had is, first step was we had to monitor, like Ganesh was just presenting you a while ago. We needed to have a good monitoring network system, because the current monitoring network was not adequate to have a good granularity of the groundwater system. So as a research project, we started this. This could be continued as an example by some other agencies, but the idea was to pick up this and create that. So what you see is that a large fraction of water to the city of Bangalore comes from the surface sources, something like about 1400 million liters per day, and a fraction of that water, I was saying, is lost to the system. So that means it's not reaching the consumers. Then the consumers are picking up from a groundwater source to supplement this information. So we need to know what portion of it is lost, what portion is gained by some other source, and so on. So you can see in this cartoon various fractions of water, the same water which is recycling in various neighborhoods. So the idea was to get a complete idea at the granularity of a neighborhood or a ward, which we call a district of a small district in Bangalore, and identify. So Bangalore has something like 200 odd wards, and we wanted to have a good water budget from a groundwater point of view. So if you see the city as such, the center part of the city is covered with surface water. The blue lines on your fourth image on the southwest corner, and then outside the city, what we mean by is the new growth city. They still it is not supplied by surface water. They are all dependent on groundwater. So the core of the city has more of surface water. The outside is using groundwater. But the Bangalore is also like a half orange, where I mean to say that the center of the city is at a higher elevation, the outsides are at a lower elevation. So there is a drainage. This is just in the first order streams. So the idea is to see how does the hydrology play in terms of the anthropogenic setting in the system. So one of the exercises was to build this layer. So you can see a link. If you are interested, you can go to the link. You can see temporal graphs of the groundwater level at all the stations. So we created a large network of stations, essentially going by something like a 5-kilometer grid for the city. The entire city is divided into 5-kilometer grids. We have about 800 square kilometer of Bangalore, and then in each grid we had several stations, so that we have a good information which goes in, and if you click in that, you will get the groundwater levels and the rainfall distribution there. Now, what is interesting is that we wanted to see what happens. Luckily, during that study, we were also looking at whether an extreme events play an important role. A while ago, I was mentioning that there can be indirect recharge pathways, not only the direct recharge pathways. So the extreme events could act on that. So one of the things which we looked at was what happens if I had a huge rainfall in 1 month due to a cyclonic storm which was happening and so on. Does it make a big change in the groundwater level? So you will see that I'm not going to spend much time, but you can see that suddenly there is a spike in the levels in 1 month, which are, so 3-4 years of loss of groundwater in one time can be recovered back in 1 month based on these. So this is also indicates the opportunities which present in terms of extreme events. How do we monetize that in terms of converting it into recharge? So we applied a model to understand how the groundwater behaves in various sections. So what I just wanted to quickly point out to you in this graphic is the highly developed area is in the middle. Outside is less developed, but more intensive groundwater use. The central core is more surface water use because the pipeline network is connected there. But if you see the statistic, the histograms, which will tell you amount of demand of water in the inner core of the city and outer core. So we tried to create it into two regions, inner core and outer core. The inner region says that this is the amount of water demand, and the outer core has this much of demand. So that means that is the demand for water, the total amount of demand as on a couple of years ago. And that how much is met from groundwater pumping in inner core. Of course, inner core, the pumping is much smaller. The outer core, for that demand, the pumping, the percentage demand met by groundwater is much higher. Whereas if you look at the amount of the water which is recharged from the rainfall is much smaller in comparison to the pumping, but the recharge from anthropogenic sources is quite high. That means the most of the pumping is met with a lot of recharge. So now if I were to look at compare between the pumping versus recharge, which is from natural sources, it would appear that the groundwater system is very vulnerable. That's why we keep hearing statements saying that we are near zero and things like that. So the idea is that how much recharge is really taking place from anthropogenic sources like wastewater, water supply utilities leaking would tell us that comes from the layer of monitoring network and the modeling protocols. By using this, you can say how vulnerable is groundwater, or how much risk it has, or how much buffering capacity we have in the system. So we also were looking at how much is the lateral fluxes from the core of the city to the outside. These are important because you want to see how things manage in a groundwater system. And just to conclude in a normal way, let's say if I have a small ward and I want to look at what does the climate bring into this. Maybe that in the future climate, my groundwater levels are likely to go down because probably my rainfalls are. So one can apply some climate models, simulation, and create what would be the future groundwater levels. This is only from a climate perspective. That means how does the rain play in, etc. But then there is also an important part saying that the humans are also managing. Let's say the water utility is managing many things. That's called the other part of it. It's not the climate part. So the water utility management scenarios are also to be considered. The management scenarios could be not only the rainfall, maybe the future can have more increase in pumping. That could be one scenario. It is possible that there could be reduced infiltration may happen from wastewater because more and more underground drainage networks are being created and taken away this water. Possibility that maybe there are enough lakes in these cities. Bangalore used to have several lakes, and some of these lakes are not anymore filling up, etc., etc. So all these can have a dimension to the overall the groundwater system. That means if I fix my leakages from water supply and wastewater pipeline, my groundwater scenario might change. It may not be the same as today. So it's important to understand a combination of these scenarios and look at how what happens. And an example of this is we consider several case scenarios and with climate, and then ask the question what would happen. So in summary, I wanted to say quickly to close the discussion, it is important that groundwater assessment in urban cities and towns, which is not a part of a present operational framework in India. Typically, operation framework of groundwater management happens in a much larger landscape where agriculture is involved at the scale of a big whole district or a state and so on. But cities itself are nearly having a 40-50% of population as we go along, towns and cities. So it's important that we need to look at this, and we need to jumpstart looking at even critical zone observatories to understand how the cities, urban cities would look like. So we need to have a good observation network, much different from Ganesh has already pointed out. There's an opportunity over here. We may have to look at interdisciplinary aspects. We just can't look at only biophysical part. We may have to look at economics. We may have to look at social side of it, and so on and so forth from these parts. And then urban flooding is gaining more and more because of probably higher rainfalls, intense rainfall. So how to utilize this urban flooding into an opportunity to store it as a groundwater is always a good store because it has a huge potential to store a lot of water. So how do we store and buffer these floods is another important aspect which we need to look at. So I stop here. I thank you for your patient listening. I thought I'll bring about a perspective from a resource which we don't see often, which is below us. We can't see it. We can't see like a lake or a stream and so on. So thank you for all the tuned people to have listened to these presentations. Thanks for for me to be in the panel.
Thank you very much, Professor Muddu. A very important topic that you were covering. Our groundwater situation is extremely critical. And on the other hand, we have urban flooding. And it is, of course, the frequency of it is increasing over time. And what we see is that we don't have enough storage spaces. Our cities had lots of urban water bodies, which were there, the surface water bodies, the lakes, the ponds, the tanks that were there. They have been systematically, encroached upon, and they have started to disappear as well. So a lot of challenges ahead of us. And last but not the least, that we need to really take an interdisciplinary approach. So while technology can definitely address a problem, but if you're looking at a long-term sustainability and equitable benefit of the technology to be passed on to different sections of the society, it's very, very important that during the planning stage itself, we need to understand the differential needs of the different people living in urban areas. Thank you very much. Now we move on to the Q&A session. So the first question that I have is to Mr. Ganesh. And I'll request you, Mr. Ganesh, to be brief because we have just about 15 minutes left and we have several questions. So the question is, we speak about so many techniques to deal with urban water supply and wastewater or discharge. I wonder how many of these solutions are urban local body friendly in terms of revenue generation. And also, the cost of this gets transferred to the consumers. So how effective, how financially viable it is for urban local bodies to really adopt these technologies.
So, firstly, I think today we are all paying money for the water that we are not even consuming, because there's so much of water that is unaccounted. So the urban local bodies are spending more than what they should be spending. So if these technologies can actually find the leakages and plug this leakage, because today there is an unaccounted water. So that way the revenue generation for the urban local bodies, or if you consider the governance system, would actually make more revenue, because these water can actually be even they get revenue out of it. So that way I think it is going to be very friendly if they actually take these technologies to the next level and properly disseminate it across in the society. So, and yeah, I think, as I said, the true cost of water is not known. The energy that is spent in this water is also not today available. So if the true cost of water is put forward to the urban local bodies through this technology, again they would be able to do the right pricing and to the right stakeholders. Is my opinion.
Yeah, thank you, Ganesh. I think that's a great answer. For almost about 40% of the water, it's unaccounted for water, or it's the non-revenue water that we talk about. So if your utility is pumping about 100 liters of water, it's only about 60 liters of water which reaches the consumers, and that's what we pay for. So sensors like this, can actually help plug these problems that are there and help in monitoring these leakages. So probably the revenue collection can go higher, because those who are taking this water or tapping the water lines which are there, they can also be traced, and a better revenue model can be worked. Also, we need to look at a progressive revenue models. So those who are consuming more should be paying more. So in cities, we have people consuming from 10 liters to 600 liters per capita per day. So probably we also need to have a tariff system which is progressive rather than the same tariff system for everyone. So I have a question for Hela. Hela, you have been you have had experience working in India. And I think all the tools that you spoke about today, they have huge relevance in the Indian context, whether it is, wastewater monitoring tools that you have, or even drinking water monitoring, wells, water quality monitoring, which you were talking about, or even for that matter, the public awareness tool. So how do you see these, like, how do we need to really contextualize these tools which you are there, or customize them for for using them in India?
I think what we can learn from the practice, what we hear, is that it needs a whole series of tools and data, but that it's also needing the intelligent use. So we are creating a lot of data today with sensors, with inline monitoring, with in-situ monitoring. And now the challenge is to really use all these data and use all these sensor information, couple them with information which is available from other places, for example, from Earth observation, from weather forecasts, as I showed it, and really apply it into decision making. And in these decision making processes, we need to bring together all actors. So not only the utilities and the technology providers, but of course also the consumers, the public, and the local bodies and the governance. And this is why, for example, in our project, we also have communities of practice on 3 levels: on the local level, on the project level, but also on a trans-project level, to really bring together the stakeholders and have a co-development and co-design. And I think this is very important, to include really all stakeholders from the beginning, and really talk about which data are the most important and how they can be integrated in decision making.
Thank you, Hela. Yes, I think I agree with you on that front, that it's important to have a multi-stakeholder approach. So on one side, we do have a very strong legal and regulatory framework when it comes to water quality management. But somewhere, the implementation has always been a challenge. And tools like this probably can make implementation also quite effective, especially also in terms of surveillance, training local people, involving stakeholder to report issues. I think it's a brilliant tool that you have spoken about. So there's one question, of course, a very simple question that is there, which I would like Professor Muddu to respond to is the concretization of urban center leading to urban flooding in a particular watershed? Huh?
Of course, concretization will lead to more flooding because the infiltration gets decreased. But then I was also pointing it out a few minutes ago, saying that the fluvial flood which causes could also create an additional recharge. So sometimes possible for water to infiltrate into the soil so quickly. But if the water is running in and goes into a ditches and locations where there are fractures, you can have a much faster recharge taking place. So it's possible that you could buffer the flood which is provoked by the concretization. So I wouldn't say that concretization only would create a flooding. The concretization also might create additional indirect recharge pathways.
Thank you, Professor Muddu. One question for Mr. Ganesh I have. See, the government of India is coming up with several programs that are there on Jal Jeevan Mission, and so that's providing tap water in rural areas. And then we have another one that's called the Atal Bhujal Yojana, that's around groundwater recharge that we have. And of course, a lot of schemes that are there on precision agriculture or water use efficiency in agriculture being the highest user of water, almost 85% of the water we use in our agriculture, that's there. So with all these schemes, how do you think the digital tools or IoT can really help in making these initiatives more effective? And also in terms of accountability, I think higher accountability.
So while the government actually has come up with very meaningful goals through Jal Jeevan mission and various other missions that you mentioned, so what is today important is how are you making sure all these things are transparent, water information to be aware to all, right? What I mean to say is water by itself should be clear and transparent, right? So likewise, even the water data should be clear and transparent. There should be clarity to water data. So that's where I think we need to work towards. And once you have this information, and also water for all is a very social subject. I mean, even a capitalist country like Israel ensured that water, even it falls on your roof, doesn't belong to an individual. So making sure the water available, water that is going, whether it in agricultural land or the cities and various places, if you actually put it on a transparent ledger and ensure that this data is available, you can come up with various services like a smart contract, and you can open it up to a lot of people in the business to actually service this. Things are very fragmented and is not available today. We are not able to come up with various, provision to ensure all these things. So we are not completely utilizing the talent pool in our country to make sure that the available water is properly utilized. So if I completely answered your question, but what I'm trying to hint towards is saying that bringing this information to one place. There are already some sites, and even a professor of mine from Indian Institute of Science, they have come up with something called IUDX, a data exchange portal for all the smart city projects, like that for water included. So this kind of effort that is Professor Amritur Barbaj at our Indian Institute of Science can actually play a very important role.
Thank you. Thank you. There are two questions quickly. I think I'll quickly respond to them because we may have to close. It's already 3:25. So the one question is, could you throw light on transportation of recycled water for gardening in apartment complexes which cannot retrofit STP but wish to reduce water footprint that is there? So now these days, you get small packaged STPs which are there, which actually the water can be taken to those packaged STPs and then used. Apartment blocks can also look at nature-based solutions. So you can have a constructed wetland or through which you can actually take that water if you're planning to use it only for gardening. The most important thing is that you need to check whether your black water and gray water, so black water is the water that gets generated from your toilets, and the gray water is from your bathroom and for bathing and kitchen water. So whether they are coming separately or not, because if they're coming together, probably then you need to really go for another level of treatment that is there. But if that, you need a biodigester. But if it is not getting mixed and you only have gray water that you want to use, then probably you can even use a small constructed wetland through which you can pass the water and then take it, use it for gardening, or use a packaged STP. So I think both can be used. And there is one question on social realities, which is, which talks about how do social realities play into access aspect of urban water, especially in developing. So I'm not reading the entire question, but I've read it earlier. Yes, we need to look at intersectionalities which are there. Right now, our water policies which are there do not look at disaggregated information. So they try to bundle everybody together, and it represents like one homogeneous group, but that's not what the society is all about. So it's important to collect disaggregated information that's there. It's important to see that our policies are socially inclusive. It's important to do gender budgeting. So women, yes, are always at the receiving end of, because they are the ones who have the responsibility to collect water. Also, while we are drafting the policy, it is important that we go and take a multi-stakeholder approach, involve everyone during the policy making itself. When projects are being executed, we need to look at different sections of the society, especially when we are looking at urban centers. Urban centers have a lot of informal settlements which are there. So we need to definitely focus on the informal settlements as well. So with that, and I would like to thank my speakers for the session today, Professor Muddu, Dr. Hela, Mr. Ganesh, for such an insightful session. Yes, managing urban water bodies is a huge challenge, especially because of the infrastructure, rampant infrastructure development that has been there. Most of the hydrological channels are closed. We have to look for new and innovative ways in which we can recharge our urban water bodies. But at the same time, if we are able to recharge our groundwater as well, we will be able to augment our urban water bodies. So policymakers definitely need to look differently to addressing problems related to urban areas, especially when we see that the water requirement is going to only increase. India, we have about 38% of the population living in urban area. By 2050, we will have about 50% of the population living in urban area. Globally, we have about 70% of the people living. So the need for water is only going to go up. Thank you very much. Thanks everyone for joining. Thank you, participants. You have been wonderful. Excellent questions coming up. Thank you to all the support staff as well. Thanks a lot once again, and have a nice day and a nice evening. Thank you.